In this bonus learning objective, we're going to look at horizontal asymptotes. So we talked about vertical asymptotes before, which are these vertical lines that when our graph gets close to them, they kind of shoot up close to those lines. They never cross those lines, but they're kind of important pieces of information. Horizontal asymptotes, the difference between vertical and horizontal asymptotes, and now the horizontal asymptote is going in this direction. So let's figure out what they are and then how to find them. All right, so one thing we're often concerned about with a function is what happens when we start plugging in really big values of x. For a lot of cases, it's not super interesting because when I plug in a big value for x, I'm just going to get out a really big value for y. All right, however, for rational functions, remember rational functions means I had the fraction bar. All right, something interesting can happen, and you're not just going to always get out these infinite numbers. All right, so look at this graph. All right, the graph of 4x minus 2 over 2x plus 1. So this is the graph if I kind of put it into Desmos when I first open up Desmos. There's not really anything interesting that's happening. All right, but let's zoom out a bit. And now you can see from my x scale, this is 140, that's negative 140. Now I'm plugging in much bigger numbers. And you can see kind of what happens to my graph. As I start going to the right and plugging these bigger numbers, my y values don't shoot up and go this way forever. You can they're almost flat here, and they're basically flat at y equals 2. All right, so this is going to be a horizontal asymptote. As my x values keep going this way, my y values are basically just leveling off, and they're at x equals 2. All right, so the way to say that is this line y equals a, which in that last case was 2, is a horizontal asymptote for my function. If when my x values get really big, my y values get close to that value 2, all right, or a, whatever the number ends up being. So in the last example, it was 2. But as I'm plugging in really, really big numbers, if I plugged in like a billion, my answer would just be 2. All right, so there's a lot of different ways to find horizontal asymptotes, but for this learning objective, I'm going to teach you the shortcut method. The shortcut method relies on knowing the highest power of x in the top and bottom of your fraction. All right, the highest power of x is often called the degree of that polynomial or that thing. So the degree is the word I'll use, all right, because it's easier to say than the highest power of x. We're talking about the highest power of x. All right, so when we're going to find these horizontal asymptotes, what we're going to do is look at the degree of the top and the degree of the bottom. All right. If the denominator, the bottom degree, is bigger, I'm always going to get 0 as my horizontal asymptote. If the top is larger, then I get no horizontal asymptote. So basically what's happening when the bottom's bigger, I get bigger numbers on the bottom, and that causes my graph to go down and level off at 0. When the top is bigger, the top gets bigger faster, and nothing's keeping it from just going up forever, and I get no horizontal asymptote. So bottom bigger, you get 0. Top bigger, it just goes off to infinity. You don't get anything interesting. And the third possibility is if they're the same. Well, if they're the same, they kind of cancel out, and you get some actual answer rather than 0 or nothing. All right, so let's look at some examples. All right, so in this case, we're going to find the horizontal asymptote of this. So what we're going to do is look at the biggest powers of x. On the top, it's x squared. On the bottom, it's also x squared. So when I start getting to infinity, this graph is like 5x squared over 2x squared. The x squareds are the same, they cancel out, and my final answer is 5 over 2. Right, so it's that much work in terms of just you're looking at the highest power of x, and then what happens if the top is bigger, one thing happens, if the bottom is bigger, another thing happens. When they're the same, they cancel out, and I just get the numbers 5 over 2. So if I were to graph this function as I go off to the right forever, my y values would be closer and closer to 5/2. All right, in this one, find the horizontal asymptote of this function. Again, we're just looking for the biggest powers of x, so this there on the top and x squared on the bottom. We'll see that 5 is bigger than 2, so this one has no horizontal asymptote. All right, whenever the top power is bigger, you don't get a horizontal asymptote. So you can go through these problems pretty quickly. Highest power on the top is there. Highest power on the bottom is there. They're the same. They're both x squared. So my final answer is going to be 3 over 6, which is 1/2. Right, so they're the same. You just look at the numbers that are in front of them and you simplify. All right, find the horizontal asymptote of this function. We look at the highest power on the top, the highest power on the bottom, and we'll see that the bottom 5 is bigger than the top 3. And if the bottom is bigger, you always get y equals 0. And here's one for you to try on your own. Again, you're comparing the highest powers of x, so they're both x squared. So then once we realize they're the same, we just look at the numbers in front of them. We get negative 10 over 2. Make sure you include that negative sign as well because it's important. Negative 10 over 2 is the same as negative 5. All right, so that's our horizontal asymptote. All right, so for the show mastery of this objective, you're going to do a skill check. All right, the skill check is going to have 4 problems and at least one of each case. So just remember, when the top's bigger, the answer is no horizontal asymptote. When the bottom's bigger, the answer is 0. And if they're the same, then you simplify and get some answer as a fraction. All right, so simple in the sense of how much work you have to do, but you have to remember these 3 different cases for how to do horizontal asymptotes.